Hi team, so let's really quickly look now at connected graphs and the role that bridges play in them. So bridges is, like, a bridge is the term for an edge that's vital to keeping the graph connected. So if you took a bridge out, it would mean that the graph is no longer connected. So let's go and have a look at one of these examples. Alright, so I'm going to start by drawing this up. So I've got, I know I should copy and paste the examples, but sometimes it's just quicker to draw these up. So I've got these vertices in there and then these edges. Okay, so first up, what we talked about was how we could make this a connected graph. So we came up with, and with using the minimum number of edges that we could. So what we came up with was that the minimum number was 3, either connecting them like such. So 1, 2, 3 edges put in, which makes it a connected graph. Or the other suggestion was that we did this. And of course there are a number of different ways that you could make these changes and add in those 3 edges to make this a connected graph. So just revisiting that and what a connected graph is. Okay, so let's start looking at these bridges. So if we've got this example here, and we've got these edges drawn in, so which of the edges are actually bridges? Which ones are vital to keep this a connected graph? So if we took one of them out, it would no longer be a connected graph. So what we did was I wrote up bridge, non-bridge. Okay. So what we're going to do is we're just going to systematically go through and one at a time remove a edge and then replace it again before we go on to the next one. So I'm going to start with AB and I'm going to remove that. So you can see there that I still have a connected graph because I can still get from A to E by taking the rest of these edges. So AB was not a bridge. And I'm going to put it back in. Okay, so back to our original graph again because I've drawn that back in. This time I'm going to take out AD. And you can see there again that my graph is still connected because you can still get from A or D to the rest of the graph. So AD was not a bridge. Okay, putting that one back in now. Again, just following the same principle, I'm going to take out BD. And you can see still that it is a connected graph because you can get from B to E by following those edges. So BD was not a bridge. And again, just putting it back in. So we're just working through by taking one out, having a look, putting it back in. Okay, so the next move that I'm going to make is I'm going to take out this BC. So what happens when I take out the BC, you can see now that I've got a non-connected graph because I can't get from E to A or A to E or even B to C because that edge is no longer there. So that B to C edge was in fact a bridge. Okay, so putting that back in. Again, each time we go to see if an edge is a bridge, we come back to our original. So taking that one out, again you can see CE was a bridge because E is now an isolated vertex. So CE was a bridge. So that means that we had 2 edges that were bridges in this example. So remembering that definition that a bridge is an edge that is vital in keeping the graph connected. All right. Let's go on to another example now. So one that we had was this one here. And it had these lines like this. So now we can again work through it systematically if we so choose, or you may be at the stage where you can simply see which ones are bridges and which ones aren't. So A, B, C, D. So first up, I'm going to take out AB, and again you can see that AB is a bridge because I now have an isolated vertex. So AB was a bridge, and now I'm going to put it back in. Okay, time to take out BC. So again you can see that BC was a bridge because now I have this A and B vertices which are disconnected from C and D. So BC was a bridge, and again putting it back in because we come back to our original graph for each test. Last but not least, the edge CD, and we can see that that last edge 2 was a bridge because now we have another isolated vertex out here with D, and we'll put it back in. So we can see that each of those edges there are vital to keep this graph connected, which means that all 3 edges are in fact bridges. So hopefully that makes sense. And next we actually move on to adjacency matrices.